Hello friends, welcome to the today's session, that is concurrency control without locking. In the last session, we learned about concurrency control with locking, which is known as pessimistic. In this lecture, we are going to learn about optimistic. So what is the difference between optimistic and pessimistic? Optimistic, it allows the conflicts, then it try to avoid. Pessimistic means before itself, it try to prevent your conflicts. Therefore, the ideology of concurrency control without locking is nothing but it allows the conflicts, and before it reaches to the consistent state, it try to cross check whether are there any conflicts or not. The following are the few varieties of concurrency control without locking mechanism. They are timestamping and Thomas Wright rule. This is a very important Thomas Wright rule. There is a Thomas Wright rule, and we also see an extension to your concurrency control is nothing but deadlock option. Now, before going into the optimistic concurrency control mechanism, that is timestamp ordering and strict timestamp ordering, Thomas Wright rule, and deadlock. We will first of all look at into our anthem, crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get plus subscription and access unlimited live and recorded lectures. About myself, Srinivasarao Sir, having 17 years of GATE experience in the subjects of DB, networks, and operating system, having relevant certifications like DBA, Cisco, and Red Hat Linux. Throughout my journey of GATE, I taught in many premium academies, including GATE Forum and MADESE 2, with a high success rate. Let us all join together to crack GATE computer science, because many of my students proved that they cracked the GATE examination in first attempt and they become alumni of IITs and NIITs. Let us you also try to crack it. Take the subscription of Unacademy, get lively classes and unlimited access to your courses. Use my referral code to get any kind of subscription for any kind of course, not only GATE. There are two types of subscriptions, 12 months and 24 months. 24 months is 2 years course and 12 months is 1 year course. This is the upcoming schedule, how I'm going to finalize and complete the DBMS subject. You also please go through it. This is YouTube lecture and this is a special class lecture slide. Please go through those timings. Let's crack GATE CSE. Subscribe to YouTube channel, hit the bell icon for latest notifications. Use my referral code to get the subscription in Unacademy. Let's crack it. So welcome to the today's session, that is timestamp ordering protocol. So what is the concept of timestamp ordering protocol? How it is going to provide a concept of consistency. This is a very important concept. We are not going to use any kind of locking system like shared lock, 2PL, S2PL, SS2PL. We are not going to implement any kind of locking mechanism. It's completely based on a validation. The validation plays a very important role in order to allow the particular transaction to access the data item or deny the request. What is the real-time example of your timestamp ordering? The real-time example of timestamp ordering is your operating system. Operating system is completely based on timestamping based only. So how does this timestamp order protocol is help in order to provide proper concurrency control in concurrent execution of the transactions in the same schedule. Now you see that what is the concept of timestamp ordering protocol. Let me derive with our own definitions apart from textbook. Textbook definitions are given here. You can go through it, but we are trying to learn cut and short manner. So how it is to be, let me explain. There are few important points are there as far as TSO concerned. TSO stands for Timestamp Order Protocol. So what is that? Point number one. Every object has two timestamps. The number one timestamp is for reading purpose, read timestamp. For writing purpose, write timestamp. Observe friends carefully these points. However, you were confident in last class concurrency control mechanism. This is also very similar. You will be very happy after solving the few problems which I kept at the back end of this presentation. So every object has two types of timestamps, RTS and WTS. Now the second point is that this RTS of object 1 and WTS of object 1 is completely different from RTS of object 2 and WTS of object 2. Friends, what I want to tell you from this particular point is that so every object has got its own two timestamps, reading and writing. Therefore the timestamp values are completely different from each other. And the point number 3, as per TSO points concerned, the point number 3 is that this RTS and WTS values are being changed every time. So friends, what is that? Your RTS and WTS values are changed every time. So I say RTS of A and WTS of A are initially always starts with 0. This is the assumption. Initially the timestamp values are 0. Now for every successful read operation and write operation, the timestamp values will be updated. So therefore this RTS on object A or any kind of object you can take it, WTS of A values are updated at every successful read and write operations. This is a mandatory point. Next point is when transaction is committed. When transaction is committed, then the timestamp values become 0. RTS of A and WTS of A is nothing but I am talking on about one particular object is being reset to once again to 0. These are the points we need to learn. Now, once you observe carefully, friends, what I am telling you, just let me give few important points to look at. There is a schedule S which consists of T1 and T2. Observe friends. So initially I am executing on object A. Initial read timestamp is 0 and initial write timestamp is 0. Assumptions. Unless and until examiner specifies this, So object A timestamp is 0 as per read concern, as per write concern. Now you observe friends how this schedule is going to react. I want to perform a read operation on object A. So when you want to perform a read operation on object A, you need to have small validation whether this object can be granted to T1 or not. So how to decide? There is a small validation. What is that? If a requested timestamp on object A is greater than is equal to write timestamp of A, then please observe friends. Why I am checking with a write? Because R will have conflicted only with the write only. Observe carefully. R has got conflict with write only. That's why this validation we are checking only with the what? Write timestamp only, as the conflict read operation may get conflict with only write operation. Therefore, friends, you observe carefully. If this is satisfied, then we can say that hello transaction to perform read operation on particular A. So read is permitted. When the read is permitted, then immediately you have to update your RTS timestamp value. So I'm saying your RTS of A is equal to the timestamp request of the corresponding transaction. So as you are doing a read operation, read timestamp will be updated. If you perform write operation, write timestamp will be updated. As I am performing a read operation, this is a read operation. To perform read, to perform read, then this is the condition is a mandatory. If it is satisfied, then allow the transaction to perform the read, then update RTS of A with TS of A. If it is not, then immediately we will do what? Roll back the requested transaction. Roll back the requested transaction. So this is the idea, friend. So now let us execute it carefully. I'm saying there is a schedule S which consists of two transactions T1 and T2. As usually we guess, I am working on object A. Initial timestamp is 0 and initial write timestamp is 0. Transaction 1 is asking for read of A. When transaction asked for read of A, we will cross check your timestamp number. I am saying you assume this is a 10 and this is a 20. Now you see friends, you are requesting T10. So T10 is greater than is equal to your write timestamp, that is 0. As this is a greater, then immediately we allow T10 to perform read operation on object A. It's a fine. And one more thing is that you update the read timestamp value. Therefore, your RTS of A, earlier it was started with 0. As this is a successful, then this timestamp will be assigned to that. Now you observe, friend, your RTS of on the particular object A is updated with your latest successful transaction which is performed read operation. Okay, fine. Now you once again go for one more example. Continue this. I am saying there is a schedule S now and T1 here and T2 here. Soon after you perform this transaction, then your timestamp of RTS of A is updated to 0, but WTS of A is only started with 0 only. So this RTS of A, after doing this transaction read operation, this is been updated to 10, but WTS is staying there in the same value. Now you observe carefully, R of A, this is granted from the previous scenario. Now transaction 2 is performing R of A now. Now we will cross check that this is the transaction 10 timestamp, this is the transaction 20 is the timestamp. I am asking once again read request only. So once again you need to check this validation. What is the validation, friends? You are coming with which number now? 20. Your 20 is greater than is equal to, what is the condition? This is a W timestamp of A. This is your request. So you are coming with 10. Your WTS of timestamp value is 0. In the same way, I am going to check. You are coming with a 20 request and your W timestamp value is 0. This is also true. Hence, you allow the T20 to perform the read operation and update your latest timestamp read value to 20 only. Therefore, whenever there is a successful read operation, then read timestamp value will be updated with the upcoming transaction number timestamp. Okay, friends, let us see once again with 2-3 transactions. Observe carefully, friends. I am saying let RTS of A is equal to 0 and WTS of A is equal to 0. I am starting with 0. Now the schedule is a begin. Observe all of you. There are timestamps given by the transaction manager of the DBMS component. Now you see I am saying R of A. Friends, now you know whether is it allowed or not. You can happily say that we are going to cross check R with W timestamp only. You are coming with a 10 timestamp. I am checking with the right timestamp value. Yes, 10 is greater than is equal to 0. Therefore, R of A is granted. As soon as you grant this, then your RTS of value will be updated to 10. Okay, friends. And now I am having a once again R of A request here. Again, we are going to cross check. This is a validation performed like this. 10 greater than is equal to WTS of A. That is nothing but 0. Here also the same validation we are going to perform. That is your requested number is at 20. This one I am talking 20 is greater than is equal to your 0. Therefore you allow this. Once soon after you allow this, your RTS value will be updated to 20 because this is a successful transaction number. Then after that, T30 requested read of A. Again same story. Your requesting timestamp number is 30 and read timestamp right timestamp value is 0. This is also true. Therefore allow it. After allowing, your RTS value becomes what? 30. This is how the chain going in forwarding direction. Please observe. So for every successful read operation, after comparing with the right timestamp value, RTS value will be updated like this. Okay, friends? Now you observe, friends. Now come to the right operation. To perform right operation. Friends, this is a very critical issue. Read operation, no problem, you can simply do, but this is a critical issue. What is a critical issue? Observe carefully. Now see, friends, when you talk about the write operation, write will be having a conflict with two actions. One action is what? Read action, and write also will be conflict with other action called write action. As we get, please understand, as we get, WR is a one conflict and WW is a one conflict. Observe carefully, friends. Earlier read operation we only perform with a write because read is having the conflict with the write only. But when you are talking about write, the write will have two conflicts. One is write with read, the other one write with write. Therefore, you need to check the validation with read as well as write timestamp. So two conditions you need to satisfy in order to allow the transaction to perform a write action on a particular object. So how come it is? Let us check it. There is a schedule S which consists of T10 and which consists of T20. And now he is asking write action on object A. So to perform write action on object A, you see a condition here. What is that? If a requested timestamp number on A is greater than is equal to, observe friends, you need to check with RTS of A as well as one more condition. If a requested timestamp on A is also greater than is equal to WTS of A. If it is satisfied, then we say that allow write. Then we say that allow write. As you perform the write operation, then write timestamp will be updated with your requested timestamp number. That's it, friends. This is the validation. You need to be checked very carefully in the event of write operation. In the read operation, we only check with the write timestamp. As we are performing a write operation, there will be a two conflicts with the write read and write. Therefore, you need to check with RTS of A as well as WTS of A to perform a write. So if this condition is failed, we know that it is going to be rolled back. Okay, friends. So using that, we start doing one small example like the reads. Assume, friends, let RTS of A is equal to WTS of A is equal to 0. This is the initial value. Unless and until you specify, you need to take this is the default value. Now, schedule as came. And there are two transactions with the T10 and the T20. All of you, please look at the screens carefully. And now this guy is requesting W of A. As soon as he requested this, now we are cross-check the timestamps values. You are coming with a 10 number. So 10 is greater than is equal to read timestamp value that is equal to 0. Yes, it is true. And then one more condition. 10 is greater than is equal to write timestamp value that is 0. Once it is 0, we can confirm that this request is allowed. Therefore, T10 can able to perform write action. After performing write action, you observe that your corresponding timestamp value will be updated with the latest transaction number. Therefore, your WTS of A is updated to 10 now. Now, friends, once again, T20 is requested. Again, same rule is applicable. You are coming with a request number. I asked the request to perform write operation. Then timestamp ordering protocol checks the validation. How? You are coming with a 20 which is greater than is equal to read timestamp value 0, and then your 20 is greater than is equal to your write timestamp value is a 10. As this is a success, then we are saying that allow this request to perform write. After performing write, your WTS of A is going to be updated with this number. Now it is a 20. That's it, friends. What do we understand? This is how in the forwarding direction the conflicts are going to be exchanged. So it is going to look at the conflicts, because as it is optimistic based, it accepts the conflicts and try to put it database into consistent state. Now let us mix read actions and write actions together, how this TSO is going to protect you. Let us see friends, one more example. Now you please be careful. I am mixing read actions as well as write actions together. So let us say RTS of A is equal to 0, WTS of A is equal to 0. Now schedule S is coming with a few transaction timestamp numbers T10 and T20 and T30. All of you please observe friends. Now T10 is coming with R of A. Now I am not going to write any validation. You know that what is going to happen. What is going to happen? We are going to check read with write and write with read and write. Therefore, read I am checking with write. You are coming with 10. 10 is greater than is equal to this 0. You know what will happen. You can chart there. So 10 is greater than is equal to 0. Therefore, you can allow this 10 and your RTS timestamp value becomes 10. Now you observe, I am asking W of A now. Listen careful friends. Now this W has to check with two timestamps, read as well as write. Now you are coming with a number is 20. Now I am going to check your 20 is greater than is equal to 10 and your 20 is greater than is equal to 0. Therefore allow this W and update this write timestamp value to 20 as you perform write action. Write action will update the write timestamp. Read action will update the read timestamp. Please observe carefully. Next I am asking R of A. I am mixing read now. You observe carefully friends. What is R of A? You are coming with a 30 number. So read is going to compare with the write timestamp. Observe carefully. Read always compare with the write. Write will compare with the read as well as write. So here two conditions. Here only one condition we will check. You are coming with what is the number friends? 30. So you are going to cross verify with the write timestamp. So your 30 is greater than is equal to 20. Therefore, it is also going to be allowed. When this is allowed, your read timestamp will be updated to this number. That is what? 30 now. Now you extend this like this. Now I am extending. He is coming with the T40 now. So I am performing this time W of A. Now need not compare. Directly you can post the answer. That is what? 40 is greater than 30. 40 is greater than 20. Therefore allow this. Update this number to 40. That's it friends. This is how we move towards forward direction. That means what it is ensuring you. If forwarding conflicts are satisfied, it will allow forwarding conflicts no problem, but it is not going to allow reverse conflicts. Please understand. So here friends, I performed write action, therefore write timestamp will be updated. Please follow. As I performed write action, so write timestamp should be updated. When you perform read action, read timestamps should be updated. Okay, that's why the write timestamp value becomes 40 as you perform the write action. So come to next example. Please observe friends. RTS of A is equal to 0 and WTS of A is equal to 0. Observe carefully all of you. Observe carefully, don't get confused. Observe carefully. Now there is a schedule which is coming with a group of actions like this. I am not going to write any kind of validation because already you know. Read checks with write, write checks with read and write. If it is greater, allow, otherwise disallow. Disallow means roll back the transaction. Okay. Now you see friends, T10 and T20 and T30 and one more transaction T40. You can type the what is going to happen to WTS and RTS values. I say W of A. Is this allowed or not? Please give your valuable comment through chat. Is WA allowed or not? Is WA allowed or not? This WA is allowed. Why? W we are going to check with read as well as we are going to check with write. Therefore, this 10 is greater than is equal to 0 and is greater than is equal to 0. Therefore, we allowed. As soon as you allow write request, execute or update the write timestamp value to the requested transaction number. So I am modifying with the reading. So it is updated to 10. So as you perform write operation, therefore WTS becomes 10. Okay, now I am performing R of A. Observe carefully, friends. You are coming with a 20 number. So R means you will check only with the write. Please observe. So 20 greater than is equal to 10. Therefore, it is allowed. So read timestamp value becomes how much? 20 now. Now I am taking W of A here. It's also allowed. This becomes 30 here. When I am saying R of A, this is also allowed. This becomes how much? 40 here. Okay, friends. Now you see, I am telling you a denying point. Carefully observe this example. I say these forwarding conflicts are satisfied as the upcoming request timestamp numbers are greater than the previous one, hence read and write actions are allowed. Now I am making disallow like this. For example, T10 turn came and he wants to perform R of A. Is this allowed or not? Observe carefully. Is this allowed or not? So R means you have to check with which timestamp? Right timestamp. You are coming with what is the number? 10. But your right timestamp value is how much? 30. Therefore, this is not going to be allowed. So when this is not going to be allowed, I said this requested transaction is going to be rolled back. So no doubt you are going to be roll back as you are not satisfying timestamp ordering protocol. Is it clear? As a timestamp ordering protocol you are not following, hence this is read request is disallowed, denied, and your transaction has to roll back it. Okay, friends. Now you see the beauty of this example. As it is rollbacking, these are also going to roll back. Observe carefully. As it is a rollbacking, these are all dependent transactions are going to be rolled back. This kind of a system is called as what? Cascading aborts. That means timestamp ordering protocol drawback is cascading abort. If one performs abort, then automatically the childs are also going to perform abort action. Clear, friends? So understand two important things I shared here. Whenever the timestamp is not satisfying RTS and WTS rules, then the particular transaction has to roll back. Whenever the transaction is rolled back, all the dependent transaction values which are in the buffers are going to be cascaded. That's nothing but they are going to perform multiple aborts. This W will be cascaded. If this is W, that is also cascaded. So all the dependents will be cascaded. Then your original value of A is going to, you are going to reach to original value of A. Now your latest timestamp value is a so far. This is a 40 and the so far this is a 30. Simply T10 is going to roll back. When T10 is roll back, all transactions are rolled back and your timestamp values are reset to 0. Here T10 and T10 leads to T20 roll back and T30 roll back and T40 roll back, and after rollbacking all the timestamp value is reset to RTS of A goes to 0 and WTS of A goes to 0. Again you have to start your actions as a fresh number. Okay friends, any doubt? Then you can post. Look at carefully. RDS of A value 0, WDS of A is equal to 0. Friends, look at, you will be 100% clear in this example. Schedule S consists of two transactions T1 and T2. All of you, please look at carefully. Now I say W of A. Is it possible or not? Please respond immediately. T2 write operation is possible or not? T2 write operation is possible or not? T2 write operation is possible or not? Yes. Then which timestamp is going to be updated? Let us take 20. Which timestamp value is going to be updated? Yes. Which timestamp is going to be updated? Right timestamp is going to be updated, right? So this becomes how much, friends? 20. Clear? Now you tell me, he is requesting R of A. Is it allowed? Question mark. Is this R of A is allowed in transaction 10? Is this R of A is allowed in transaction 10? Is this R of A is allowed in transaction 10? No. Why? Because 10 is not greater than is equal to 20. Because read is going to check with the right timestamp. Please observe carefully. So you are coming with the what? 10. And here it is not greater than to your 20 and this is not possible. Then T10 is going to do what? Roll back. So here T20 is not going to be rolled back. Why? Because T20 is not dependent on you. Please observe carefully. So T20 is not going to roll back. It's like that only. Just T10 is going to be rolled back because it is not satisfied timestamp ordering protocol. Clear? So T20 won't be rolled back. T10 will be rolled back, but T20 not roll back as it is. It is not roll back because it is independent action. It is not depending on anybody. It is a first action and independent action. Therefore, T20 is not going to perform any rollback action here. Come to next example. I want to tell you RW, WR, WW conflicts, how they will come in timestamp ordering. These are all allowed in TSO. Please observe carefully. All these timestamps, these conflicts are allowed in timestamp ordering protocol. Why and how? Please have a look at this. RTS of A is equal to 0. WTS of A is equal to 0. So please look at the previous diagram, friend. Initially, I performed W of A. Please observe carefully. Initially, I performed W of A. So therefore, T20 is not depending on any transaction. T20 is not depending on any other transaction. Therefore, T20 is not going to roll back. Earlier situation is different. T20, 30, 40 depends on 10. As T10 is rolled back, then all others are going to be rolled back. But as this is independent, this is the first perform. This is the first perform, and that too it is independent. I have not dependented. Yeah, correct. Now look at this example now. Please see, there is a schedule S which consists of T10 and T20. Observe friends. So in T10, I performed R of A. All of you, this is possible, right? So RTS becomes 10. Now I am performing W of A. This is also possible. WTS becomes 20. So which conflict it is? Please respond. Which conflict this is? Which conflict this is? You can say that the conflict which we are talking about, RW. So RW and WW conflicts are allowed in timestamp ordering. But what is disallowed? I will prove you. And second, let us continue forward direction. So T30, he wants to perform R of A. This is also possible. And this 10 becomes 30 now. So you observe carefully. There is one more conflict here. There is one more conflict here. What is the conflict? WR conflict. So this is also allowed. Come back like that. I want to prove the last conflict also. I am saying T40. So he is asking W of A. This is also allowed. This becomes 40. And T50, W of A. This is also allowed. Therefore, you see that all the three conflicts are existed. All the three conflicts are existed in this example. So understand friends, RW is there, WR there, WW is there. Finally, after satisfying all your transactions, your latest timestamp value of WTS of A is 50 and RTS of A is 30. Clear friends? After updations, RTS value on object A is 30 and WTS timestamp value on object A is 50. Okay friends. Now, what do we understand? You please see T10 here and T20 here and T30 here and T40 here. You are going to look at the conflicts in a forwarding direction. What is the forwarding direction? T10 to T20 there is a conflict. T20 to T30 there is a conflict. T20 to T40 there is a conflict. Likewise, you see that conflicts are going in a forward direction. It's not coming in a reverse direction. Hence, you can come to know that it is a what? CSS. You observe carefully, friends. You can say that it is a CSS as it is going into forwarding direction. Clear? Now I will tell you how it is going to deny reverse conflicts. Observe all of you. Now you see RTS of A is equal to 0. WTS of A is equal to 0. Understand friends? Now there is a schedule S. We can say that it's a transaction 10 and transaction 20 and transaction 30. Please observe. I am saying R of A and W of A. These are allowed. With our knowledge, you can say it is 10, this is 20. Now I am going back this time. I want to perform write of A. Now you see this is disallowed. Why this is disallowed? because you are testing with 10. 10 is not greater than is equal to 20. Therefore, this is not possible. So when this is not possible, you see that you have forward conflicts like this, but you see that this reverse conflict is not there. Therefore, it never goes into a loop back concept. So it goes into forwarding direction only. It never have a chance to go back. So we can confirm you never get a concept of what cycle in precedency graph. You never get any cycle in precedency graph. Therefore, it guarantees what? CSS. It guarantees CSS. Why? Because this edge is not there. As it is not allowed, please see, this W of A is not allowed. Hence, you have only R and W conflict only. Therefore, there is no reverse WW conflict. So, your structure, if you looks like T10 and T20, will fall into only forwarding conflict. There is no reverse conflict. So, what timestamp ordering is guarantee you? It always gives you conflict serializable schedules. Clear? So let us see what are the strengths of timestamp ordering. Strength of timestamp ordering that it guarantees CSS. This is your previous gate question, and no deadlock. It is guarantees CSS and there is no deadlock. Why there is no deadlock? Because you never see a concept that two transactions are waiting for each other, such that when I say R of A, if your timestamp is greater than 2 me, therefore it allows. Otherwise it rollbacks. Two conditions only. Why no deadlock? Why no deadlock? Two conditions. Either you allow or rollback. There is no concept of what? Waiting. Please understand. Either you allow or roll back, no chance of waiting for others. No chance of waiting for others. Therefore, you never see a concept of what? Deadlock in this. We are not going to wait for others. Please observe, friends. We are not going to wait for others. Why? If your timestamp is greater, you will be allowed. If it is not greater, it will be rolled back. But you never wait for others. Therefore, there is no chance of deadlock in timestamp ordering protocol. Clear, friends? There is no waiting chance. Please observe. There is no waiting at all. Why? Because if your number is lesser, you will roll back. If your number is greater, you will be accessed. So what are the drawbacks? Disadvantages. We understand it is going to give you cascading aborts. This is the point 1. Then there may be a chance of irrecoverability. There may be a chance of irrecoverability. Why? Please observe carefully. Yeah, this is also very, very important point. What is that? There is a schedule S, transaction T10 and transaction T20. I am saying W of A. This is granted. He just read of A. This is also done. Please observe carefully, friends. This example is very, very important. Initially, T10 performs write action and T20 also performs read action. Both are allowed. Why both are allowed? The first one is T10, it's granted, and second one is T20, it is also granted. But he issued commit. It is also possible. If owner wants to do abort, then it is not possible. This is a situation of what? Irrecoverability. Therefore, there may be a chance of irrecoverability in this case. These are the two drawbacks of your, what I mean to say, timestamp ordering protocol. Okay, friends. So come to the point. Which of the following actions are allowed? Please understand carefully. Point number 1. Every object timestamp, every object read timestamp and write timestamp starts with 0. Yeah, you're right. Now you observe. Now you observe carefully. So object A or object B, object C, all objects, the read and write timestamp values are zeros only starting. Now which of the following are allowed? Understand. So schedule S, T10, all of you please look at carefully. T20 and T30. Ready? Now listen. W of A, R of A, R of B, W of B, W of A, W of B. Are they allowed or not allowed? Please understand. Which of the actions are not allowed in this? Which of the following actions are not allowed in this? Which of the following values are not allowed in this? Following actions are not allowed in this. Observe carefully, friends. Which of the following actions are not allowed in this? Please see, you follow with me. So, T20W of A is success. Please see. Therefore, as I performed W of A, this becomes 20. Okay, friends, observe carefully. Next, R of A, you are coming with a 30 number. R means I am checking with right. So 30 is greater than 20. Therefore, this is also allowed. So your RTS on A, I am talking about on A. This is 20. This is 10. Observe carefully. And now I am coming back. So I am coming back like this. R of B. Don't think that B is a values consist of 10 and 20. Again, you need to take care of that. RTS of B is equal to 0. WTS of B is equal to 0. Because every timestamp value is going to start with 0 only. Therefore, as you are requesting for B object, so it is no problem. RB is allowed, WB is allowed. This becomes 10 and this also becomes 10. Clear? And come here. I am coming with a 40 and I am trying to access A and B. So 40 is greater than 20 and 40 is greater than this 10. Therefore, this is also allowed. This becomes 40. And WB, 40 is greater than 10 and greater than 10. And this value becomes 40 here. Therefore, it is also allowed. It's a perfect example for timestamp ordering, how it is going to execute on the objects. Okay, friends? So let us look at the another variety. So this is how the timestamp protocol works. So timestamp ordering is optimistic based, which is try to provide CSS, but chance of cascading aborts and irrecoverability. Therefore, there is a requirement called STSO. What is STSO? Timing 2. Timing 2, this is object B. Object B here. So object B, again it is, you need to start with the 0 values only. Every object has got its own starting value. These three values, I am saying A values only, timestamp 20 and timestamp 30 on object A. But I am starting afresh with object B. Therefore, you need to see that your starting value is 0. Because as I said that every object RTS and WTS starts with what? 0. So come here. So what is a strict timestamp ordering? It is a strict plus timestamp ordering. Friends, what is the meaning of a strict? We learn. Strict main intention is no WR and no WW. What is the meaning of that? Every write operation need commit or abort before sharing with others. Yeah, so you're all worrying about this. What is that? Every object, please understand, every object timestamp values are initially 0. This is applicable to RTS on A as well as WTS of A, RTS of B, WTS of B dot 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 2, RTS of object N, WTS of object N. Okay? Unless and until examiner specified, please observe this rule carefully. Unless and until examiner specified, all the default values are initially zeros only. So come to the previous one. So come to this. What is this? Strict timestamp ordering protocol is following a strict property with the rules of timestamp ordering. So what is the advantage? The advantage is we are learning STSO. Advantage is it guarantees CSS. Point number 2, no cascading aborts. Point number 3, it always gives you recoverables. A recoverable as following a strict property. As following strict property. Okay, friends. So let us cross check. The example is, please once again you all look at the examples carefully. The example is like this. Let RTS of A 0 and WTS of A 0, RTS of B is equal to 0, WTS of B is equal to 0. Now you look at the schedule as T1 and T2, W of A. Please observe, friends, all of you. W of A, the timestamp number to this is 10. The timestamp number to this is 20. These are the timestamp numbers given by database management system, that is a transaction manager is allocating this timestamp numbers as we are following a timestamp ordering protocol. Observe carefully, right? These are the initial values I am assuming. Now you see W of A is granted, right? Now you tell me W of A is T20 allowed? Is T20 allowed in timestamp ordering? Question mark. Is T20 allowed in STSO? Question mark. Please all of you. First question, is T20 allowed in timestamp ordering? Second question, is T20 allowed in strict timestamp ordering? So first we confirm it is yes, because your number is 10 and my number is 20. So TSO forwarding conflicts are okay. But in STSO, what it is telling you? You require a commit or abort before it is sharing with others. Therefore, this is not possible as there is no commit or abort statement is there in this. Clear, friends? So this is the difference between TSO and STSO protocol. STSO protocol is a guarantee that, so whenever you are talking about STSO, then you see that no WR and no WW. You need to be look at these two conflicts carefully. So come to the last example. I am telling you, every data object RTS and WTS is equal to 0. Schedule as I am following STSO. Please observe carefully. So when you are talking about STSO, no double write with read conflict, no write with write conflict. Every write operation requires a commit or abort statement before it is sharing with others. That is the meaning of strict property. When you are calling a strict property is saying that every write operation requires a commit or abort before it is sharing with others. This is mandatory. Every write operation requires commit or abort before sharing with others. That is mandatory. Therefore, WR is disallowed, WW is disallowed. In all the three conflicts, the dangerous conflict is WR only. WR conflict is a main conflict, as it is going to give you irrecoverability chances. So come here, I am following STSO protocol. So T10 and T20. Now you look at carefully, R of A and R of A and 30 W of A please observe friends 40 W of B. Is it allowed in STSO? Is it allowed in STSO? Observe carefully. Is it allowed in STSO? Is it allowed in a strict timestamp ordering protocol? Is it allowed on strict timestamp protocol? Yeah, please observe. Strict timestamp protocol is mainly talking with the write action only, no read action. Please observe carefully. STSO main intention is write action only. So this is allowed. And this is also allowed. This is also allowed. This is object B. It's not A. Please observe carefully. It is not object A. It is object B. If it is object A, then there is a requirement of commit or abort here. As it is not object B, then you can say that this is not required. It's quite alright. Okay friends, so what do we understand? This is also allowed because this is a different object by name called B. So there is a requirement of commit or abort only onto the same object, not onto the different objects. Clear? This is object B. That's why you need to be very careful in exam. This kind of small twist you will get. Object A and object B and object C. You need to be very careful with eyes, good eyes. Clear? So come to the next example. Again, every object RTS and WTS is 0. Point number 1. So schedule as T1, T2 and T3, T4, W of A, R of B, W of B, R of A and W of A. Question number 1. Are these allowed? Are these allowed in TSO? Question number 2. Are these allowed in STSO? Just answer to my question. Question number 1. Which is correct? Yes or no? Question number 1. Yes or no? These are your timestamp values 1, 2, 3, 4. And your timestamp value is starting with 0. Yeah, very nice. So question number 1 is what? Yes. All are allowed. Question number 2, no. Because of this, we are saying that it is no. Because there is a requirement of commit or abort statement here before it is sharing with the T4. Clear friends? Yeah friends. So come to the last one, that is Thomas Wright rule. This is a very important. So what is Thomas Wright rule? Let me tell you. T10 and T20. Please observe, friends. Salary is equal to 100. RTS of A is equal to 0. WTS of A is equal to 0. Now you see, so they are initially given with the 0 values. WTS of A is equal to 0. Now you see R of salary. Observe, friends. So when you say R of salary, this is a fine. This A is nothing but salary only, don't get otherwise. This is salary. This also salary. So RTS of salary is equal to 0. WTS of salary object is 0. Okay. Now I am performing read of salary. It's a fine. Its value becomes 10 now. Now you see salary is equal to sal plus 100. Write of salary. So your salary becomes 200 now. Okay. Salary is initially with 100. So I come to know that salary is equal to 100 here. This is shared to others. I am talking about timestamp ordering only. So salary is equal to sal plus 100. Write salary, it becomes 200. It's acceptable. Now you observe, I am coming back with salary is equal to sal plus 100 and W of sal. Is this allowed? Is this allowed or rollback? Question mark. Is this allowed or rollback? All of you. Is this allowed or rollback? Is this allowed or rollback? Your timestamp number is a 10 and the other timestamp number is 20. Is this allowed or not allowed? Please see. Initially, as soon as you perform, some values on this, RTS of salary is equal to 0, WTS of salary is equal to 0, right? Now by performing a read salary, once this is allowed, the timestamp value is updated to 10. And when you ask the write of salary 200, the timestamp value becomes 20. Again you are coming into the loop T10. T10 is coming, so you are coming with which action? Write action. Write action means it has to greater than to read as well as greater than to write. What is your number? You are coming with same number 10 only. So 10 is greater than is equal to 10, but it is not greater than is equal to 20. Therefore, what happened? This is going to roll back. This is going to roll back. So when it is a rollback, because you are coming with a late timestamp number 10, when it is a going rollback, then your salary becomes how much? 100. Please understand carefully. Your salary once again goes back to 100 and this write operation is going to be cancelled. And this write operation is going to be cancelled. Because of the cascading abort, you depend on him. T20 depends on T10, hence this write operation is going to be cancelled. Your salary goes to how much? 100. So I am in question mark. Ambiguity, inconsistency in T20 that I performed plus 100, but this time plus 100 is lost because somebody is rolled back at my value. This is the problem with the what? Timestamp ordering. So the main problem with timestamp ordering is that there may be a chance of what? Rollbacking of your transactions in the events of this kind of write and read operation. Now come to the point. What the Thomas Wright is telling you. So Thomas Wright rule, it is exception to write operations which violates TSO rules. Which violates TSO rules. Now you observe, so what is the meaning of write operation? And the point number 2 is that Thomas Wright rule must be used with timestamp ordering similar to TSO only. Similar to TSO. Okay, so I will give you shortcut. Only 2 examples. It's bus. 100% it reached you. So observe carefully. Let RTS of A is equal to WTS of A is equal to 0. Schedule as T10, T20. I am following Thomas Wright rule. Observe friends. So I say salary is equal to 100. When I say read salary, this is fine. Salary is equal to 100 you will get. This is shared him. Salary is equal to sal plus 100. Write off salary. This becomes 200. When I am saying salary is equal to sal plus 100 and I say write off sal, what will happen? What will happen? T10 will roll back or not? This is the question. T10 rollbacks or not? All of you observe this. This T10 will roll back or not? No. Why no? Please observe. The answer is not yes. It is a what? No T10 rollback. That is the power of Thomas Wright rule. It is not going to give you any kind of inconsistency to other transactions as your transaction is not rollbacked. Because of this one. What is that? Please understand friends. What is that? It gives an exception to write operations which violates Thomas, that means what? Timestamp ordering rule. Therefore, what is our strategy? Even you are coming with a violation, but it is not going to do any kind of rollback of T10. Therefore, T10 write operation is known as obsolete writes. These writes do not have any impact on your database. Therefore, they simply just cancel this salary. So your salary is staying at 200 only. So T20 is not rollback, T10 is also not rollback. So your salary is staying at 200. without any rollback of your transactions. That is the power of Thomas Wright rule. Exception to write operations which violates the rules of timestamp ordering. Therefore, write actions can be ignored. Write actions can be ignored who violates timestamp ordering protocol rules. Yeah, once look at this, friends. There is S and T10 here and T20 here. Observe carefully. We are saying, please observe, friends. T30. Yeah, every time the n times write operations can be ignored. Why? I will show you the proof, just follow. So salary is equal to 100. Please observe, friends. Read salary, it's a fine 100. Write salary, it's a fine 200. Write salary, fine 300. Write salary 400. Write salary 500. Now you observe, friends. What is that? This is allowed. This is allowed. Right? This one is ignored. This one is ignored. Therefore, your salary value without any rollbacking is how much? 300 only. This is the power of Thomas Wright rule. So, the right actions which are violating the timestamp ordering protocol will be ignored. They will not be written to the disk. Therefore, your transactions are not going to be rolled back, which doesn't cause any kind of inconsistency to others. Clear, friends? Another example, I am working on Thomas Wright rule. Schedule as T10, T20, T30, salary is equal to 100, read salary 100, write salary 200, assume plus 100 I am doing with write operation, write salary 300, write salary 400, write salary is 400. Now tell me, friends, what is your salary value? What is salary in TSO? What is salary in Thomas Wright rule? Two questions. Answer to my question. What is salary in Thomas Wright rule? What is the salary in timestamp ordering? All of you, in Thomas Wright rule, what is the salary? This can be ignored, right? So therefore, it's a final value 400. In timestamp ordering, what is our salary value? What is our salary value? So Thomas Wright rule, late writes are going to be ignored. Therefore, it is a final value, it will store here. And Thomas Wright timestamp ordering, what will happen? This is the problem. So when it is a problem, it rollbacks. So when it roll backs, it gone back to what is your value? 100. As you read your 100, so it goes back to 100 because you just perform 100 to 200 here. So this is going to be lost and this is going to be lost. And finally, your value is 100 in this case. Clear, friends? All of you. So this is the difference between TWR and timestamp ordering. So Thomas Wright rule protects protects your transactions from your late write operations which violates the timestamp ordering rules. So last example, we say salary is equal to 100, T10 and T20 and T30. Read salary, write salary and write salary. I am using Thomas Wright rule. Read salary. So 200, 100, 300. What is the salary? What is the salary? Please observe. What is the salary? What is the salary in this example? So I'm using Thomas Wright rule. So this is okay, this is okay, this is okay. What about R cell? What about R cell? All of you. I'm asking Thomas Wright rule. I'm asking Thomas Wright rule. So what about R salary? Why? Why it is 100? Why it is 100? It is 100. Why? Because Thomas Wright rule only for write, not for read. Observe, friends, all of you observe carefully. Thomas Wright rule exception is only for write operations, not for read operations. Whenever there is a read operation, immediately it has to roll back. So in that case, TWR is equal to exactly TSO. TWR is exactly TSO because you are performing not write, you are performing a what? Read operation. So Thomas Wright rule is only for writes, not for reads. So whenever read violates the Thomas Wright rule, immediately are going to be what? A rollback. Okay. Well, friends, now we will look at into deadlock. So transactions are bound to each other, to acquire objects. Point number 2, deadlock chances only for with locking approaches, with locking mechanisms. For example, T10 and T20, X of A, right of A, X of B, right of B, x of B, x of A. Please observe friends carefully. This is the situation I am giving you. Is it deadlock or not? Is it deadlock or not? So observe carefully friends. This is done. I am using a locking technique. I am using a locking mechanism. Please observe all of you. This is the last example. So x of A right performed, x of B right performed. So both are given to each other because different objects. Now I am requesting here. So you will be under waiting. He is requesting through this. Therefore, you are under waiting. So this is called what? Deadlock, because it is a never-ending process. It's a never-ending process. That's called deadlock. So how to detect the deadlocks? How to detect deadlocks? The only one point, that is timeout mechanism. And the second one is what? Waits for graph. Timeout mechanism are also called as waits for graph. So what is a waits for graph? Please observe carefully. If graph forms a cycle, then it is a deadlock. Okay friends, now let us see one example on this. T10 and T20, x of A, w of A, x of B, w of B. I am deriving graph now, T10 and T20. Observe carefully. So T10 has object A, T20 has object B. T10 has object A and T20 has object B. Now what 10 and 20 are doing extra? In order to complete T10 and T20, they need one more object. That is, it need A, it need B. It's not possible. As you are requesting to him, as he is requesting to you. Therefore, this is how you are requesting to him and it is requesting to you. Therefore, it is a concept of what? Cycle. Hence, we form a concept called deadlock. So, there is a requirement of deadlock preventions. Deadlock prevention schemes. Number one, wait and die. Number two, wound and wait. Wait die policy and wound wait policy. What is a wait die? Please observe friends. Older transaction waits for newer transactions. otherwise dies. And what about wound weight? Older transactions kills newer transactions, otherwise waits. That's it, friends. We will take one example on that and close the issue. Please look at T10 and T20, Exxon A, WA, Exxon B, WB, Exxon A, Exxon B. This is the scenario. Now, what will happen in weight die? What will happen in wound weight? Observe carefully. T10, T20, T10, T20. Observe, friends, all of you carefully. So 10 has A here, 20 has B here. This is old transaction. This is a new transaction. Why I am saying this is old and this is a new? Because its timestamp is lesser than this timestamp. Please observe. 10 timestamp is lesser than 20 timestamp. Therefore, 10 is older than 20 is newer. 10 is older, 20 is newer. So there is a cycle. Now, how to break this deadlock using weight and die policy? Observe, friends. The definition is telling you that old transaction waits, newer transaction dies. Older transaction waits, newer transaction dies. Please observe carefully. Therefore, T10 is an older transaction. T10 waits. T20 dies. Clear? T10 waits. T20 dies. Ready? So when it dies, what will happen? When it dies, your graph is modified. Your graph is modified like this. After prevention, what happened? T10 and T20, observe, friends, it is having A, it is having a B. This edge we will follow. This edge we will cancel. Understand? Please observe. This edge we will follow and this edge we have removed, as new is a what? Dies here. So finally, what do we understand? It is no cycle. Therefore, this is how you can able to prevent the deadlock using weight and die schema. So what about wound weight? XA, WA, XB, WB, XA, XB. This is the situation. So we have T10 here, T20 here, and it is requesting on to that, and it is requesting to this. It is A and it is a B. Now there is a cycle. So we confirm it's a deadlock. So we want to apply wound weight this time. So what is a wound weight? Wound weight is nothing but old kills new and new weights. Old kills new and access that object. And new transaction is going to weights. Therefore, as T10 is old, it just kills this 20 and access this object B like this. Now, for example, T10, T20, T30. So please observe 3 transactions 10, 20 and 30. Right now the T20 has got object X. Okay. T10 is requested to 20. T30 also requested to 20. Request. Okay. T30 requested for object. So for example, there is object A here. Now, if you are using weight die, what will happen? If you are using wound weight, what will happen? Weight die, wound weight. Last 5 minutes, friends. Observe carefully. Yeah, what is that? T30. Compare T10 with T20. Two transactions only you compare. You are requesting to 20, he is also requesting. So compare like that. T30 is requesting to T20. T10 is also requesting to T20. Two cases there. Now in that case, what will happen? T10 waits. In that case, what will happen? T30 dies. As you are newer and this is a older. Please observe. In this case, again, T10 versus T20. So what happened in this? T10 kills T20. What happened in this? T20 with T30. T20, T30 with T20. So T30 has to wait. That's it, friends. So in that case, how T10 reacts? In this case, how T10 reacts? Requesting only how to write left hand side. These are the requested items. These are the requested items. This is the holder. Who is holder that? That's it, friends. So this is how you can able to prevent the deadlocks using weight die and wound weight. Therefore, there will not be a concept of what cycles. So I will give you one homework. Do it. The homework is like this. This is your homework. T10, T20, T30. It is requesting to this. It is requesting to this. It is requesting to this. Okay. In weight die, what happened to T10 and T20 and T30? The deadlock is observed. And in wound weight, what happened to T10 and T20 and T30? Okay, friends. Now, you please solve this homework. If you have any doubts, we will look at in the next session. Tomorrow, your class is at 2 p.m. YouTube class, and a special class is at 7 p.m. Please see, YouTube is 2 p.m. I am starting with the constraints, and the special class is at 7 p.m. These are your tomorrow's timings. So on YouTube, I'm going to start constraints, how to implement weak relationship. Special class, I'm going to start select clause, TCL select clause, group by having clause operators. Okay. So once you do this homework, tell me in next session. Thank you. Thank you all of you.